Hello everyone, welcome to this very special lecture on trigonometry. But before we start, let me wish you a very happy Diwali. This is the season of festivals, and for you it is double fun because your festival of Diwali is here and your festival of Tier 2 exams are also here, right? So let's celebrate our Diwali and Tier 2 together. So what we'll be doing in this lecture? We'll be doing a quick revision in today's lecture of trigonometric concepts, the important trigonometry concepts that are necessary for Tier 2 exams. Now how would we do that? We will be taking questions, okay? These questions have been designed in the likeness of the questions that have been coming in the past few years in SSC CGL Tier 2. And we'll solve those questions. In each one of those questions, we'll be showing you how to approach the question, what concepts would help you to do the questions fast. Okay? So that would be the approach of doing those questions. The questions are divided into certain categories. Now these are those categories from which trigonometric questions are given by the SSC board in Tier 2 exams. So in each one of these category, I would also tell you what are the important concepts in here. Obviously, we cannot revise all the concepts because it's so vast, but I'll give you an idea about the concepts that you should be knowing. So that if you want, after today's lecture, you can just go through and very fast within 30 minutes to 1 hour, brush up those important concepts, formula of trigonometry. Okay, right? So that would be our approach today while doing this revision on trigonometry with these very important questions. So let's start. So this is our first question. Try it out and then we will solve it. Done? Okay. First, let's see what kind of question is this. As you know, we discussed that we will be doing questions in groups in the kind of categories that they come. Now this question is from that category, the category which comes the most in the SSC exams, and that is the questions based out of basic identities. Okay, right? So there are different kinds of basic identities question. This one is a conditional one, conditional basic identity question. Then there are absolute value basic identity question, then elimination of variable basic identity questions. So all of those questions, we'll see a glimpse of all of those questions as we move ahead in the lecture. Now this one is, as I told you, a basic identity question, conditional one. Now first of all, I'll tell you a little about the basic identity question, the resources that you need to solve the basic identity questions. Now, as you know, the trigonometry is based out of the basic concept of right angle triangle. So obviously, if you have a theta, the sine theta, the cos theta, what are they? This identification, I am sure that at this stage all of you have. Okay, so sine theta is equal to perpendicular by hypotenuse, cos theta base by hypotenuse. So that idea is something that you already have, I am assuming it. Now in basic identity question, apart from this idea, what you need is to know a little about the three basic identity equations, and which are they? First one is sine square theta plus cos square theta is equal to 1. Right? Second, sec square theta minus tan square theta is equal to 1. And the third, cosec square theta minus cot square theta is equal to 1. So all of these three comes under the basic identities of trigonometry because they come directly from the Pythagorean system of understanding trigonometry. Okay? Right? So let's see how would we approach this question. Now what did I say? This question is a type of conditional question, isn't it? Now what is the catch with the conditional questions? What do we need in there? The first thing that students try and find out in conditional question is, where do I start from? Do I start from the condition or do I start from the expression of whose value we will have to find out? Now, in such cases, the decision is very simple. If the condition is simple, then you start directly with the expression. But if the condition is not simple, if the condition itself does not give us direct idea about what it wants to say, then we start with the condition, just like in this case. In this case, we do not have a simple conditional equation. It is a complex one. So, we will have to solve it first, find out sin theta or theta value or cos theta value, and then from that we will be able to solve the expression. Okay, right? So, let us start with the equation first. There is a limiting factor also which will come to play when we have solved the equation. 3 tan square theta minus 3 tan theta, okay, plus 2 divided by sec square theta is equal to 1. So, this is minus here. Now, from this equation we can very clearly see that this sec square theta can go in here, and we know from the basic identity that sec square theta is nothing but 1 plus tan square theta, because one of our basic identity is sec square theta minus tan square theta is equal to 1. So, this equation can be rewritten as 3 tan square theta minus 3 tan theta plus 2 is equal to 1 plus tan square theta. Yes or no? Right? Now, this tan square theta comes here, this 1 comes here, and our equation becomes 2 tan square theta minus 3 tan theta plus 1 is equal to 0. Right? Now, you can obviously solve this equation. I hope that you have that idea of how to solve equations such as these, and very simple, break them into middle term factor. One would be minus 2 tan theta and another would be minus tan theta. So, when you put them together, you will have two roots of this. One is 2 tan theta minus 1 into tan theta minus 1 is equal to 0, right? So, you can do that, 2 tan theta common from 2 tan square theta minus 2 tan theta. So, that here we will be left with tan theta minus 1, and the same here. Here we will take minus 1 common. So, that would be clubbed together, this would be clubbed together. Now, we have two roots to tan theta. Now is when the limiting factor comes to play. This is the use of the limiting factor. What does the limiting factor say? That the theta should be greater than equal to 45 degree and less than 90 degree. Now, can tan theta be half? Even if you do not know the theta value at which tan theta is equal to half, that doesn't matter. But you know the range that tan theta starts from 0 at theta is equal to 0 and goes up to 1 at 45 degree. So, half would be between 0 to 45 degree, because from 45 degree till 90 degree, tan theta goes till infinite, right? So, tan theta half cannot be a value in this limiting condition. So, the only value that tan theta can take in this condition is 1, right? Hence, we know that theta should be 45 degree according to this limiting condition after we have solved this equation. Now, we have found the value of theta. What do we do now? Simple, put it here. So, sin 2 theta is sin 90 degree, which is 1, plus sec 45 degree. Sec 45 degree is how much, my dear friends? Yes, it is root 2. Okay, plus cosec 90 degree, which is also 1. So, you have 2 plus root 2. Your answer here, answer B. So, option B is your answer here. Clear? Okay. So, this is how you solve this question. Now, one thing you should remember is that the basic values of sin cos theta, they have to be remembered. For example, sin 0 is equal to 0, sin 30 is equal to half, sin 60 root 3 by 2, sin 90 1. Similarly, cos 0 1, cos 30 root 3 by 2, cos 60 half, cos 90 then 0, right? And if you remember the sin and cos, tan, cot, sec, and cosec all would follow because you can find them out. Sec is the reciprocal of cos, cosec reciprocal of sine, tan and cot comes from sine and cos only. Okay, so you'll have to remember just the sine and the cos values. Okay, chalo, the next question. Another question of basic identity based on conditionals. Try it out. Done? Okay, let's see. See here, this is what I say, a simple condition. In the last one, we had a condition which was not simple. So therefore, we had to solve that. And obviously, therefore, it will take a little more time than this one where the condition is very simple. So we will directly attack the expression. Now we will have to solve the expression though here. So cosec theta plus cot cube theta into sec theta. Right. Now here cot cube theta into sec theta. Cot cube theta is nothing but cos cube theta divided by sin cube theta. So 1 cos theta and sec theta can cancel, right? Therefore, I can write this as cot square theta into cos theta by sin theta into sec theta. Yes or no? I take out 1 cot theta and make it cot square theta. So this cos and sec gets cancelled. I have a 1 by sin theta. 1 by sin theta is nothing but cosec theta. Cosec theta. So cosec theta can get common from here. So our expression becomes 1 plus cot square theta inside the bracket and outside cosec theta. Yes or no? Now I know 1 plus cot square theta is what? Cosec square theta. Now outside there was cosec theta and inside there was cosec square theta. So what will be our final answer? Cosec cube theta. Now you have cosec cube theta, but here you have the value for sin square theta. So what do? We know that cosec cube theta is nothing but 1 by sin cube theta. Now here I need to find out now sin cube theta. Now here a little bit of algebra would be needed, very basic algebra. Indices you remember. In indices you had would remember that you had studied x cube can be written as x square to the power 3 by 2. Yes or no? This is something that you can write in surds and indices. So these two gets cancelled and you have x cube. So here also, because I have been given sin square value. Why do I need the square value? Because I have been given that only. I can write sin cube as sin square theta to the power 3 by 2. Yes. Now sin square theta can be replaced by 1 plus x square and you have 1 plus x square to the power 3 by 2. Now what are the options here? 1 plus x square to the power minus 3 by 2. Now this is nothing but 1 plus x square to the power minus 3 by 2. Right. So this should be our answer. This should be our answer. So let's look at the other options too, but you don't need to because you have already got your answer. X cube, 1 plus x square to the power 3 by 2, 2 plus x square, all can be eliminated. Okay. Okay. So our answer in this case is answer A. Clear? Chalo. Next question. Okay, try it out. Done? Now, this is a question which is of trigonometry can be most easily be solved through algebra. Very basic algebra. Let me tell you one thing of algebra which would help you to solve this very quickly. There is a theorem in algebra which says if xy is equal to 1, that is product of xy is equal to 1, that means one is the reciprocal of the other, then the value of this expression 1 by 1 plus x to the power n plus 1 by 1 plus y to the power n, whatever the value of n, would always be equal to 1. Okay. This is the theorem of algebra that we are referring to. You all have done algebra, so you will know this theorem obviously. And you know, in the exam body, the questions of this type are automatically given so that they can check that whether you have that capability of cross-functional application skill. So directly use this theorem, this concept and mark 1. Why? Because here see, if I assume this to be x, right, and I assume cosec to be y. So sin theta into cosec theta has a relationship of product being 1 because 1 is the reciprocal of other. So that xy is equal to 1 factor is being satisfied here. So therefore I can easily use that concept to solve this question. So our answer is 1. Hardly 5 to 10 seconds. If the last two questions would have taken you around 45-50 seconds, this should have taken you not more than 5 to 10 seconds. That's how you would save time, na? Right? In some of them you would take a lot less time, in some of them you would take more time. Okay, so now we will go on to the next question, and the next question is on your screen now. You have this question, try it out. Done? Okay, good. So here we have another condition that has been given to us. 11 sin theta minus cos theta is equal to 0. I have forgot to write the if and the limiting factor is there. Then what is the value of this expression? So what do? This is a very simple one. We will just solve it very fast. 11 sin theta minus 7 cos theta is equal to 0. That means 11 sin theta is equal to 7 cos theta. So can I say tan theta is equal to 7 by 11 by bringing cos this side, right? So tan theta is 7 by 11. Now what do I do in the expression? 11 sin theta, this is the expression, minus 5 cos theta divided by 22 sin theta plus 13 cos theta. This expression value we need to find. Now if I have got tan theta, therefore it makes sense that I convert the expression also in terms of tan. So let's see here, how can we do that? By dividing denominator and numerator by cos theta. So what would we get if we do that? We would get 11 tan theta minus 5 divided by 22 tan theta plus 13. We'll get this, right? We know what is the value of tan theta. The value of tan theta, my dear friends, is 7 by 11. So then if I replace tan theta by 7 by 11 here and 7 by 11 here, I'll get here 7 minus 5 in the numerator, okay, and in the denominator I'll get 2 into 7, 14 plus 13. So what do I get? 2 by 27. That's my answer. That is answer A. Right? So this is my answer. How much time would you have taken? 30 seconds at the max, right? So that's what I told you at the start, that we'll be doing questions that have been coming, or the kind of questions that have come in SSC CGL Tier 2, and we'll see how much time we should be investing in solving these questions. That will also give you an idea about how much time you should be taking for these kinds of questions. Next question. Okay, look at the next question now. Done? Now, what is this kind of question? This is a new kind of question. This is a basic identity question only, but here we will have to eliminate variable. Okay, now what is eliminate variable? Now eliminate variable is that, you see here you have an expression that has been given to you where there is cos theta and it has been given in terms of P and Q. Now you'll have to find out cosec theta in terms of P and Q, right? So no theta in the options. Okay, so this is elimination of variable. Let's see how would we do it. There is no rocket science behind it. The simplest way of doing it is to solve or simplify this, and we will do that only. What has been written here? 1 plus cos theta divided by 1 minus cos theta is equal to P square divided by Q square. So if I cross multiply, then I would get Q square into 1 plus cos theta is equal to P square into 1 minus cos theta. Now, in this, how would we approach now? Simple. You bring the cos together and the P and Q's together. So, what will you get? You will get P square plus Q square cos theta is equal to P square minus Q square. See, when we open this bracket, we will have a minus P square cos theta. That would go this side, and therefore it would become plus P square cos theta. You already had a Q square cos theta. So P plus Q square common. So P plus Q square cos theta is equal to, now here you had a Q square which when goes this side become minus Q square. So P square here, P square minus Q square. Simple. So from this we know that cos theta is p square minus q square divided by p square plus q square. When you have this with you, can you find out sin theta, cosec theta, sec theta? Yes, you can find tan theta, you can find anything. Why? Because we know from the basics of trigonometry that height square plus base square is equal to hypotenuse square. And therefore, from that we know that sin square theta plus cos square theta is equal to 1. Hence, if I have a cos theta, I will also have a cos square theta, and I can find the sin square theta by doing 1 minus cos square theta, and that is what we are going to do here. We will do p square minus q square divided by p square plus q square. Remember this, okay? P square minus q square divided by p square plus q square. This is cos theta. So therefore, to have sin square theta, I will have 1 minus cos square theta, which is 1 minus p square minus q square whole square divided by p square plus q square whole square, right? Okay, so if I take an LCM and do this, I know p square plus q square whole square minus p square minus q square whole square. So I know all the p to the power and q to the power 4 terms would cancel, and what I will get is 2p square q square, and here 2p minus 2p square q square. I will just write it down so that you know. 1 minus, this is our expression, okay, p square plus q square whole square. Okay. Now, when this is for sin square theta. When I simplify it, I will have in the numerator p to the power 4, q to the power 4 plus 2 p square q square minus here minus p to the power 4 minus q to the power 4 plus 2 p square q square, right, divided by p square plus q square whole square. This I am doing to make you understand. You don't need to do this. If you have done a little bit of algebra, you know that a plus b whole square minus a minus b whole square is always 4ab. Okay, so from that only you can do. But nonetheless, you have now got the value 4 p square q square in the numerator and p square plus q square whole square in the denominator. But this is sin square theta. We need cosec theta. Okay, so let's first make cosec square theta. So cosec square theta is nothing but p square plus q square whole square divided by 4 p square q square, right? So cosec theta would be root of it. So our numerator should have p square plus q square and our denominator should have 2pq. So is there it? No. Is there it? Yes, the second option. We see the second option as the answer here. Okay, right? We get it in here. So our answer is answer B. Tick. That's how you approach these questions. Now, obviously in many places you can jump steps, and you should be, because then only you will be able to do it faster. Next question on your screen. Done? Okay. Before I move forward, just to make myself clear, jump steps does not mean that you do it wrongly. Jump steps means the steps should be done inside your mind and write down the results. You cannot jump all steps, but 1 or 2 steps in between could be jumped. Okay. Do it according to your comfort level, but to do it faster, you'll have to do it in a way so that you do not write down all the steps. Obviously, you'll be doing all the steps in your mind, but don't write down, because writing takes time. Okay, this is the second kind of question of eliminating variable. Here, you have 2 expressions equating together. So what do? We assume, in these kind of question, we assume both to be equal to k. So I'll have a value sin A to be k into, k is a constant, k is any constant, k into A, and cos A to be a value k into B, right? Now, I'll have to find sec A and cosec A. I'll have to find sec A and cosec A. See, finding sec A and cosec A is very simple. Why? Because I know sin A is k into A. So therefore, cosec A is 1 by k and sec A is 1 by kb. But until and unless I find out the value of k, how would I find out the value in terms of only a and b. I will not be able to eliminate the variables. Na? So therefore, we will have to find out the k value first, and that can be only done from the basic identity. Square both and add. So on the left hand side you will have 1 sin square a plus cos square a, and on the right hand side you will have ka square into a square plus b square. So now you have a value of k square, and which is 1 by a square plus b square. So basically k would be plus minus root over 1 by a square plus b square. We will see how would we apply it, whether only the positive root would be applied or negative root according to the options. But now we can directly juxtapose sec a as to be 1 by cos a and cosec a as to be 1 by sin a. I know 1 by cos a is 1 by k into b and 1 by sin a is 1 by k into a, right? So if that's the expression in front of us, I'll take 1 by k common, and if I take 1 by k common, okay, I'll have 1 by a plus 1 by b, which is equal to 1 by k into a plus b divided by ab, right? So this is what we have. What was the value of k? You remember the value of k was plus minus root over 1 by a square plus b square. So now I can put it here and look at the options out here. There is no negative option, so I will only put the positive one. So I have a plus b divided by ab into root over a square plus b square. Is there any option like that? ab no, this no, this one, c1 is your option. Okay, so I am solving this to the last and going to the option. You might do it in between also. Here also you could have gone through the option. You do not need to solve it till this end. I am solving it so that you understand the process by which we are arriving, but you should have done at this step only, checking the option. Okay? Because you know that in the denominator there should be ab root a square b square. This is not there, this is not there, only this is there. So you will only have C. Take. Chalo. The next question would be on your screen now. Then try and do this question first. Done. Okay, what kind of question is this one? Now this is another different kind of question. This is also a basic identity question, but this is a finding absolute value question. I told you, there are three kind of basic identity question, where only basic identities would be able to help you to find out the answer. No special identities, nothing. And that's the beauty of this exam. In SSC CGL Tier 2, though trigonometry is a part of advanced maths, what you need to know mostly are those 70-80% things which are basic in nature. Okay, we'll see that. Why it is called absolute value? Because you have been given an expression, you'll have to find out the value of it. How do we do it? Simple. You'll have to simplify the expression that has been given to you. Right? That's the only way that you can do it. So let's try and do it. You have done this question. So what are the different ways we can approach this? Remember, in basic identity, finding absolute value questions is where value putting helps us a lot. Why is it so? Because here you do not have any condition, and therefore you can experiment with value putting, because if you go by the traditional method, it might take you more time. In this question, I will show you both the methods. Okay, the value putting also and the traditional method also. I also tell you how to choose values while putting values. Right. First, the traditional method. How do we approach this question traditionally? You see, here you have a numerator and a denominator. Let's divide the numerator and denominator first so that you understand it clearly. So what is the numerator here? The numerator here is cos A divided by 1 minus sin A plus 1 minus sin A divided by cos A. Right. So this is your numerator. Let's simplify it. If I take an LCM and simplify it, what would happen? Cos square A plus minus sin A plus sin square A, and you would have a 1 and you will have a minus 2 sin A, right? Okay, and here you will have cos A into 1 minus sin A. Okay, right? So cos square A plus sin square A 1. So you have 1 plus 1 2. 2 minus 2 sin A. If I take 2 common here in the numerator part of the numerator, then you will have 1 minus sin A, and here you already had 1 minus sin A. So I can cancel these two. So what you will having? 2 by cos A is your numerator. What is your numerator? 2 by cos A, or you can write 2 sec A, whatever you like. Okay, right? That's your numerator. Remember that. Now we will go on to the denominator. Denominator has been given as tan square A plus 1 plus sec A divided by 1 plus sec A. Now this is your denominator, my friends. So what do we do in here? Simple. You would make tan square A plus 1 as sec square A, and you will take sec A common. So you will have 1 plus sec A in bracket, and here also you will have 1 plus sec A in bracket, which gets cancelled, and you have sec A. Right. So your numerator, you remember 2 sec A was your numerator, and your denominator now is sec A. So 2 sec A divided by sec A is equal to 2. Your answer should be D. Answer D. Okay? This is your answer. So this was by the traditional method. How much time would you have taken if you have practice and if you have your concepts at the right place? 45 to 50 seconds for this. Let's do it faster through value putting method. What value should we put? Remember, while putting value, the best values to put is 0 degree or 90 degree in trigonometry. Why is it so? Because this can make substantial part of your expression 0, leaving with you a smaller part of the expression and thereby easy to calculate. Okay? But there is a limitation to this value, and the limitation to this value is that if in the denominator, if you have tan or cot kind of stuff, or even cos kind of stuff, tan and cot in the numerator also, there would be problems. Why? Because tan 90 is infinite. Cot 0 is infinite, undefined rather. Okay. So all of these undefined characters in value putting we will have to avoid. So if such kind of stuff is happening with the given expression, then we will move on to the next set of values, and we will talk about the next set of values in a moment. Let's first see whether using 0 degree gives us any result or gives us unfavorable result. Unfavorable result means in any way some denominator becomes 0 or not. So in the numerator there was a denominator 1 minus sin A. So sin A is 0, therefore 1 minus 0 1. So this is okay. Cos A was in denominator, cos 0 is 1, so there is no problem. The whole denominator term here, I know tan A is 0. So this part would be 0, but 0 plus 1 would be 1. Therefore the denominator does not become 0. So we can use 0 degree. So then we will use 0 degree and show you. Cos A is 1 divided by 1, 1 plus sin A is 0, 1 minus 0, 1, and then you have cos A 1. So 1 plus 1 here divided by now the denominator. Tan square A divided by 1 plus sec A would be 0, plus 1 is 1. So what do you get? 2. 2 is your answer. Okay. So when you put A is equal to 0 degree, you get your answer. Clear? Okay. So that was the value putting method. So I showed you in both the ways. Now let's move on to the next question. Same type of question. Try it out by yourself. Done? Okay, great. So let's see here. As we saw that in value putting, the time that is taken is lesser. For example, in the last one we saw, if we had taken 45-50 seconds for the traditional way, then in the value putting way 15 to 20 seconds. But we should also know that in every expression value putting will not be possible, and therefore in that condition we should be knowing the way to traditionally solving it, and that's why I showed you both the methods. Now in this particular case, let's do it with value. What did I tell you? That the best value is theta is equal to 0 degree or 90 degree. Now would you be able to do it in here? You cannot, because you have both tan and cot. So if you take either 0 or 90, there would be an undefined character. So I cannot take 0 and 90, both are ruled out. So what is the next best? When there is tan, and even without tan also, the next best according to me, I find it easier, is 45 degree, especially when there are higher powers of sine, cos or any other even higher powers. So why even higher powers in theta is equal to 45 degree? What does it do is that theta is equal to 45 degree, sine theta cos theta is 1 by root 2 and tan theta cot theta is 1. So there one part of our expression becomes simplified because I will have to take tan theta cot theta 1. But in sine theta cos theta also, the values would be not in root form if there are even powers of cos and sine. Okay? Then and hence we find it easier. So let's do it here. 45 degree. So 1 by root 2 to the power 6. So 1 by root 2 to the power 6 is how much? Would be half to the power 3, which is 1 by 8. So this part of our expression becomes 1 by 8 plus 1 by 8 minus 1. Okay? And this part of our expression becomes multiplied by 1 plus 1 plus 2. So this is how much? This is 1 by 4 together, and 1 by 4 minus 1 is minus 3 by 4. And this is how much? This is 4. So 4 cancels, minus 3 is your answer. This is your answer. This is how fast you can do this question. And you know what? The basic identity values that they normally give in SSC can be done with value putting method. The basic identity questions of absolute value question type questions. Okay? So you should take the full benefit of it. Achha, the traditional way, how could you have approached it? Simple. You take cos square theta and sine square theta, okay, and cube them, and use the a cube plus b cube formula here to simplify it, and it would be done. But yes, that would take a little more time, maybe 1 minute or maybe sometimes more than 1 minute also. Okay, but then if you know the right way to put values, you would be done within 20 seconds. Next. Done? Okay. What do we do here? Again a basic value putting question. This is what they had asked. What is the expression of the value of this expression? So here see, there is a denominator again, there is a numerator again. So how do we do it? If you had done it in the traditional way, for example, traditional way also here would have worked. Numerator, you have sec root over sec theta minus tan theta divided by sec theta plus tan theta. Now this is a very simple case because you had already sec theta minus tan theta. So therefore if I multiply the numerator and denominator by sec theta plus tan theta, the numerator becomes 1 because it would become sec square theta minus tan square theta, which is 1, and this would become sec theta plus tan theta whole square. So by numerator would become what? 1 by sec theta plus tan theta. Okay. On the other hand, my denominator here, denominator is 2 cos theta divided by 3 1 plus sin theta. So this can be written as 1 by sec theta into tan theta into 3 by 2 1 plus sin theta divided by cos theta. Okay, na? So this could have been there. This is sec theta plus tan theta. This could have been there. Achha, this cos theta, if it is multiplied here, then what would become to this part of the denominator? This part of the denominator would become 1 plus sin theta. So you have 1 plus sin theta at here. So this gets cancelled and you have 3 by 2 as your answer, which is option number B. So this is one way you can approach this question. This is one way you can approach this question. This was an easy one. You could have done it in the traditional method also. What is the other way? Put theta is equal to 0. How do we know we can put 0? See, sec theta, tan theta at 0 is 0 and sec theta at 0 is 1. Therefore, it doesn't matter. The denominator does not become 0. Of the numerator part's denominator does not become 0. Also, in this part, you have 1 plus 0, which is 1. And this is your 1. Cos theta is cos 0 is 1. So therefore this denominator is also not becoming 0. Therefore we can put 0. If you put 0, then what would happen? Sec theta minus tan theta. Sec 0, 1 minus 0 divided by 1 plus 0 root over. Okay, divided by 2 cos theta, 2 into 1 cos 0 1 divided by 3 1 plus 0 3, 1 plus 0 is 1, 3 into 1 3. So here I have 1 and 1. So what do I get? This 3 gets up. I have 3 by 2 as our answer. 15-20 second I know our answer. Okay? Chalo, next one. The next question on your screen. Done? Okay, let's look at it. 1 minus 3 sin to the power 4 theta plus cos to the power 4 theta plus 2 sin to the power 6 theta plus cos to the power 6 theta. How do we approach this question? Now in this question, tell me, can you put 0 degree? You would say that the expression does not have any denominator. We can put 0 degree, right? We can put 0 degree. There is no problem with that. But no, you cannot. Why? Because look at the option. Sin theta by 2 is an option and 0 is an option. So at 0 degree, sin theta by 2 is also 0 and 0 is also 0. Similar, cos theta by 2 is also 1 and 1 is also 1. So none of the options you could eliminate. Similar, at 90 degree, you will not be able to eliminate any option. So if you are putting value and you are not able to eliminate any option, what good is that? It is of no use. So therefore, you will not use 0 on 90 degree, you will use the next best. What is the next best? 45 degree. So if I use 45 degree, my dear friends, here, how would you do it? 1 minus 3, 1 by root 2 to the power 4 plus 1 by root 2 to the power 4, this is in bracket, plus 2, 1 by root 2 to the power 6 plus 1 by root 2 to the power 6, this is also in the bracket. So I know that 1 by root 2 to the power 4 is half whole square. So 1 by 4, 1 by 4, 1 by 4 plus 1 by 4 is half. So I have a 1 minus 3 by 2 here, plus here half cube. So 1 by 8 plus 1 by 8 is 1 by 4. So I have 2 by 4 here. So this cancels and becomes half, right? So 1 minus 3 by 2 is minus half, and here I have plus half, minus half plus half 0. Now I know that my answer is 0. If I had put 0 degree, I would have got confused between all the 4. But now I know that it is definitely 0. Answer is D. Chalo, the next question now. Okay, another type of question now. Done? Now, first let me tell you what is this type of question. As I am telling you for each type and giving an idea about what kind of concepts you would be using. Obviously, we cannot in this short class do all the concepts, but I can give you an idea so that you remember that these are the areas to which you have to refer to for these kind of question. So what is this question? This is the question from Quadrant and values and graphs. Okay, this is the area from where this question has come, and the subsequent 1 or 2 question would have also come from here. So what is the quadrant concept? First, let me tell you about the quadrant concept. So this is the quadrant. Now this quadrant is called the quadrant of all. That means all values of sine, cos, tan would be positive in this quadrant. This is the quadrant of sine, this is the quadrant of tan, and this is the quadrant of cos. In this quadrant, sine and cosec values would be positive only. Others would have negative value, cos, sec, tan, cot. In this quadrant, similarly, tan and cot values would be positive. And in this quadrant, cos and sec values would be positive. Okay, right. So these are their quadrants. So you will have to remember this way, anti-clockwise A, S, T, C. Okay, anti-clockwise A, S, T, C. So this is a basic concept. I am sure that you already know it. Now, how do I apply this to do question? Simple. Sin x is 4 by 5 and x is in the second quadrant. Then what is the value of tan x and cot x? So first of all, second quadrant means the quadrant of sine, right? This is the quadrant of sine. Now here sine value is positive. Okay, so that's what I see here. But tan and cot would have negative value, right? Okay. Now here you also see that sin x is 4 by 5. So sin x 4 by 5, this is a Pythagorean triplet. We know that there are Pythagorean triplets in right angle triangle, basic natural number triplets, like for example there is 3, 4, 5, there is 6, 8, 10, 5, 12, 13, 7, 24, 25. So this is 3, 4, 5 wala, right? So hypotenuse is 5, this is 4 perpendicular and 3 is base. So here tan x would be how much? Absolute value wise tan x would be 4 by 3 and cot x would be 3 by 4. But here they would be negative in nature because they are in the second quadrant. Okay. Achha, why 4 by 3 and 3 by 4? I am not explaining it because it's very basic. From right angle triangle, if you have sin x, therefore you can find out tan x, and if it's a Pythagorean triplet, cos x, tan x, everything you can find out. I suppose you know that. Okay, right. So now here these values are absolute values, but these would be negative in nature because these are in the second quadrant. So minus 4 by 3 minus 3 by 4. What is the value? LCM 12. Minus 4 into 4 minus 16, minus 3 into 3 minus 9, minus 25 by 12. So your answer is minus 25 by 12. This is your answer. Simple, right? Very easy. And you would not believe me that there are around, if 40% of the question comes from basic identity, normally 20% or so questions come from this area. 20 to 30% comes from this area. Okay, next. Do it. Done. Okay, what is the question? The question says, if sin theta is equal to root 3 cos theta, what are the possible values of sec theta plus 2 cos theta? Now, possible values of, why? Because see, tan theta here, from this we can say tan theta is equal to root 3. Now, you would jump to conclusion that tan theta is equal to root 3. That means theta is equal to 60 degree. Yes, theta can be 60 degree, but theta can also be 240 degree. Right, theta can also be 240 degree because then it would be in the tan quadrant where also tan would have positive value. Okay, so we'll have to keep in mind both the values. Okay, in our mind. So sec theta and 2 cos theta. Let's see. Sec theta and cos theta in this quadrant would be both negative, and sec theta and cos theta in this quadrant would be positive. So if theta is equal to 60 degree, the answer would be positive. If theta is equal to 240 degree, it would be negative. But how would we know? Therefore, possible values. So you'll have to check out with the option. Okay. But nonetheless, the value, absolute value, modulus value would be the same of this expression. Whether it is positive or negative, the absolute value would be the same. So let's find out the absolute value. Okay. And we'll see then whether the positive sign is there or the negative sign is there. So let's assume for the absolute value, let's assume 60 degree. Let's assume. So sec 60 degree would be how much? Sec 60 degree is 2 and cos 60 degree is half. 2 into half 1. So 2 plus 1 3. So this is my absolute value. This is my absolute value. So my answer would be either 3 or would be minus 3. So let's see. 1 by 3 no, 0 no, 2 and a half no, minus 3. So minus 3 is there. So therefore I know now that this expression had been given at theta is equal to 240 degree. Okay, right, 240 degree or higher powers of that. Okay, so multiples of that. So my answer would be answer minus 3. Clear? Okay, so easy na? Chalo, next question. Another question, the same concept but a little more application of it. I'll show you how to do it. But try it out first. Okay. Now, done. Now, sin 65 degree plus theta, cos 25 degree minus theta, all are there. But you have to understand here what is the concept behind it. The concept behind it is that if you have a quadrant and there is a quadrant, always remember that sin 90 degree minus theta would be is equal to cos theta. Similarly, cos 90 degree minus theta is equal to sin theta. I hope that you know that. So all odd power of, whenever you have a odd power of 90 degree minus or plus theta, then minus or plus theta, then your function changes. Your function becomes the converse function of that. So tan becomes cot, sin becomes cos, sec becomes cosec. ठीक है, whenever there is an odd multiple of 90, 270, then further down the line, so 1 into 90, 3 into 90, 5 into 90, all those, minus plus both. Acha, here it is positive, minus plus cos theta plus sin theta, but if it had been sin 90 degree plus theta, then also it would have been positive. Yes, then also it would have been positive. Why? Because 90 degree plus theta is in which quadrant, my dear friend? It is in the quadrant of sine, and in the quadrant of sine, sine's value is always positive, therefore the value would be cos theta, plus cos theta. But if it had been cos 90 degree plus theta, then it would have been minus sin theta. Why? Because cos in second quadrant is negative, so negative value would come, but the values, absolute value would be same as sin theta. Okay, right? This is the concept behind it. So we can convert therefore any function of sine to cos by this method. Achha, what happens if there is sine 180 degree minus theta? First of all, if it is an even power of 90, that is 2 into 90, 4 into 90, stuff like that, then nowhere does the function change. The function remains the same. It will be sin theta. The sign, positive negative, depends upon in which quadrant it is. 180 minus theta is in this quadrant, 180 degree minus theta. Matlab, this is in this quadrant, sine quadrant, therefore positive value. But if it is cos 180 degree minus theta, then it would be cos minus cos theta. Why? See, 180 degree minus theta, even power of 90, therefore the absolute value would be same, cos theta. Function would not change, but the sign would change. Why? Because cos in the second quadrant is negative. Okay? So this is the basic concept on which we will be doing this question. I hope that you already have an idea. If if you have an idea, my just saying this much would have given you an idea that how much you could have done here. Okay, right? Now let's look at the question here. There is a numerator here and there is a denominator here. So first let's look at the numerator. Acha, numerator sine 65 degree plus theta minus, now cos 25 degree minus theta can be written as cos 90 degree minus 65 degree, okay, minus 65 degree plus theta. Yes or no? It can be written as that, right? Also in the numerator there was plus cot square 15 degree minus sec square 75 degree, right? Okay, cot square 15 degree minus sec square 75 degree. So here you have the numerator. So this can be changed to what? Cos 90 degree minus a form. So this becomes sine. Acha, does the sign change? No, it is in the first quadrant, so all positive. So this becomes sine 65 degree plus theta, and this part becomes minus sine 65 degree plus theta, right? So and you already had a cot square 15 degree minus sec square 75 degree. Now can I write cot square 15 degree the same way as tan square 75 degree? Now can I write that? I can write that very easily, that cot square 15 degree is nothing but tan square 75 degree, right? So I have sine 65 degree plus theta minus sine 65 degree plus theta cancels, and here I have tan square 75 degree minus sec square 75 degree. So this is sec square theta minus tan square theta wala form, but multiplied by minus. So I can write minus 1. So this becomes 0, 0 minus 1, minus 1. So my numerator becomes minus 1. What is my denominator here, my friends? See here, sine 79 cos 11. Can cos 11 be written as cos 90 minus 79? Yes. And cos 90 minus 90 degree minus 79 degree can be written as sine 79 degree. Hai? It can be written as sine 79 degree. So I have two sine 79. So this becomes sine square 79 degree. Similarly, this becomes cos square 79 degree the same way. So sine square theta plus cos square theta is equal to 1. So denominator is 1. So minus 1 divided by 1, you have Answer option A. Okay, right? So this is your answer. Clear? Now, next question. The next question again the same type, but here we have increased the difficulty level by joining two different kinds of questions. Try it out. Done? Now, see this part here we are seeing that 47, 43 makes 90 degree. So, whenever there is a 90 degree addition on two complementary angles, you would know that you can use that 90 minus wala form. But here there is a different one. Here 47 plus 13 is not 19. So, what is this kind of question? This kind of question, the numerator can be done just as we did it. So, let's do the numerator first. The numerator would be cos 43 is sin 47. So, you have 2 sin 47 degree into, now you also know here that sec 43 is cosec 47. So, cosec 47 plus cosec 47 is another 2 cosec 47 degree. So, numerator say sin 47 cosec 47 gets cancelled and your numerator becomes 4. So, your numerator value is here. Now, let us go to the denominator value. So, remember your numerator value is 4. What is your denominator value? Now, denominator you have sin 47 degree into cos 13 degree plus cos 47 degree into sin 13 degree. Now, looking at it, do you recollect the compound angle formulas? Sin A plus B. Sin A plus B is sin A plus B is sin A into cos B plus cos A into sin B, right? So, that's the form that we are seeing here, na? So, this is compound angle. Now, compound angle is the larger group from which multiple angles, submultiple angles, all of those flow out. Okay, so that's a larger group of compound angle where we need to understand the transformation from sum to product, product to sum. So, these kind of. So, these are all formula based, yes, but some basic formula would do. So, if you remember sin A plus B formula, okay, if you remember cos A plus B and cos A minus B formula, sin A plus B, sin A minus B formula, tan A plus B formula, okay. Similarly, if you remember sin A plus sin B formula, okay. So, then only your half of the job would be done, and multiple and submultiple angles can be derived from the compound angles only. If you recollect them, remember them, good and fine. If you don't, just derive it. Okay. Now, coming back to this question. So, if I take this to be A and this to be B, I see this is nothing but sin A plus B. So, 47 degree plus 13 degree. So, this is sin 60 degree, right? So, we have our answer here. Denominator is sin 60 degree, which is root 3 by 2. So, if sin 60 degree is root 3 by 2, then your numerator was 4, this was root 3 by 2, you are having 8 by root 3 as the answer. Your answer is this one. Okay? Right? That's how you do it. Do this. Done? Okay. Now, let's look at again a formula that comes from here, but not a direct one. We know that cos A cos B minus sin A sin B is cos A plus B. But here I have just the minus of that. So, I can write this as 1 minus cos A plus B, right? I can write this as 1 minus cos A plus B. So, 1 minus cos A plus B is 0. So, cos A plus B is equal to 1. So, when is cos 1? Cos is 1 at 0 degree. Cos is 1 at 180 degree or pi, cos is 1 at 360 degree or 2 pi. So, all multiples of pi and 0 degree, right? Acha, theek hai. Now, what I have to find out is 1 plus cot B tan A. Now, listen to me very carefully. If I have this with us, only for 0 degree and 180 degree you need to find out. Because for 360 degree and then higher powers of pi, it would repeat. Okay. So, let us say cos is equal to, if it is 0 degree, let us say, then if A plus B is equal to 0, if A plus B is equal to 0 degree, then A is equal to minus B, है ना? Then tan A would be is equal to minus tan B. Yes or no, my friends? है ना? Because we know that A is equal to minus B, so tan A is equal to tan minus B, and tan minus B is equal to minus tan B. So if A plus B is equal to 0 degree, I know tan A is equal to tan minus tan B. That is 1. But what if is A plus B is equal to pi? Then A is equal to pi minus B. So A would be here pi minus B, right? Now what is tan A then? I know tan A is tan pi minus B. Now pi minus B is second quadrant where tan is negative. So therefore this would be because pi is 180 degree, it would not change the function, but it would change the sign. So minus tan B. So in both 0 degree 180 degree, tan A is equal to minus tan B. Can I use this information from the solution of the equation that I did that was given? I can, na? Because now I know tan A is equal to minus tan B, replace it. So this expression becomes 1 minus cot B into tan B, right? So cot B into tan B becomes 1. So 1 minus 1, 0. Our answer is 0. Clear? Okay, that's your answer. Sure. Next question. Do this. Done? Great. So let's see. How do we do it? Now here you would see that you'll have to use how you'll have to use, you'll have to innovate. So cos 20 degree plus sin 20 degree, cos 20 degree minus sin 20 degree. If I have to simplify, I have all the options as cot, tan. So if I have to simplify, do it in the tan wala formula. So divide everything with cos, numerator, denominator with cos 20 degree. So in the numerator you will have 1 plus tan 20 degree, and in the denominator you will have 1 minus tan 20 degree. Okay. So this can be written as, 1 is what? Tan 45 degree. So can I write tan 45 degree here and here tan 20 degree? And can I write 1 minus tan 45 degree into tan 20 degree? I can write that. Na? I am representing this in this form so that I can use the formula. What is the formula? Tan A plus B. This is the formula of tan 45 degree plus 20 degree. And I know that this is nothing but tan 65 degree. So this is my answer. This is my answer. Right. Next question. Now this is the maxima minima question. Try it out. Done. Now in here what you should know, I'll tell you a basic thing first. If you have an equation such as this, A sin A, or let's say M sin A plus N cos A, then what is the maxima and minima value of this? Plus minus root over m square plus n square. This is the maxima is plus value and minima is the negative value. Remember this always, right? Just directly apply it and then you would be very finely doing this. Mostly of this form it comes. You can also go ahead and look at the other maxima minima value for the other functions, but this is the most popular one. So let's look at here. What does it say? 24 sin A plus 7 cos A, this is the expression, plus m is greater than equal to 0. So this is the condition that has to be satisfied. So if this is the condition that has to be satisfied, so and it has to be greater than equal to 0. So whatever value is minimum of this, whatever value is minimum of this plus m value should be at the least be 0. Whatever would be minimum plus m, which gives 0, would be the minimum value of m. It cannot go beyond that. Okay. Now what is the minimum value of 24 sin A and 7 cos A? If you have identified that this is a pair of Pythagorean triplet, remember 7, 24, 25, then you can very finely say that the minimum would be minus 25. If you haven't, then just do it minus root over 24 square plus 7 square. 24 square plus 7 square if you do, you would get it's 25, which is root over is 25. Okay, so you get that minus 25. So you have the minimum value as minus 25. Now if this is the minimum value of this expression, then what should be m? M should be plus 25 to make it 0. M should be plus 25 to make it 0, and that is the minimum value of m that can be. Because m cannot be less than it. If m becomes less than it, let's say 20. If m becomes 20, then what would happen? It would become less than 0, and that is not possible according to the condition given, right? So m's minimum value is plus 25. Remember that the expression's value, this expression's minima is minus 25, but they haven't asked that. They have asked what is the minimum value of m, right? And that is plus 25. Clear? Okay? So that was the last question on trigonometry. We'll do very fast 2 questions on heights and distances also, because though in tier 2 very less heights and distances come, but still there are some heights and distances questions that come, and you should know the basic idea of it. So try it out. Done. Okay. Before I move on further, let me give you a shortcut of heights and distance. Now always remember a shortcut of heights and distance, that if a very popular category is 60 degree, 30 degree angle. Okay. So if it's a 60 degree angle and let's say this base is given, so opposite to 60 degree, whatever would be the side is b root 3. Okay. You can prove it also, if there is time you can prove it yourself also. Tan 60 is equal to b, height by b, and therefore height is equal to b into tan 60. So you can do that, but you at least remember it. Anything, if the one adjacent side is given to the 60 degree, the opposite side to the 60 degree would be that side multiplied by root 3. And if this is given, let's say h is given, so the opposite side of 30 degree would be h by root 3. Okay. This makes your calculations very easy. See? So if you have done this question, let's move forward. The angle of elevation of the top of a building from the foot of the tower, so is 30 degree, and the angle of elevation of the top of a building. Okay, so there is this building, and there is this tower. Okay, and the angle of elevation from the of the top of the building from the foot of the tower. So this is tower, this is building. Let's say this is 30 degree, and this is from the foot of the building is 60 degree. Okay. If the tower is 90 meter in height, the tower is how much, my dear friends? 90 meter in height. What is the height of the building? So see here, you know that this is 90 meter and this is 60 degree, so this is 30 degree. So you know that this is 90 divided by root 3. This is 90 divided by root 3 because opposite to 30 degree. And if this is 90 divided by root 3 and this one is your 30 degree, so opposite to 30 degree you will have this height. So this height would be 90 divided by root 3 divided by root 3, right? So this 3 comes in here, 90 divided by 3, which is 30. So you have 30 meter. So you have your height. Your height is 30 meter. Okay, right? So this is the way you can do the questions of heights and distance very fast. You'll have to just to remember that the angle opposite to 60 degree is adjacent side multiplied by root 3. The angle opposite to 30 degree is adjacent side divided by root 3. So we did 90 divided by root 3 here, and then we did 90 divided by root 3 divided by root 3. So we had this one. Okay. Now the next question, we will do one static one and one moving one. This is the moving one question. Done? Okay. Now let's see this. The angle of elevation of an airplane from a point on the ground is 60 degree. So this is 60 degree, let's say. Okay, this is 60 degree. And after flying for 50 seconds, let's here, and that is 50 seconds, the angle of elevation changes to 30 degree. So this becomes 30 degree. Okay. Height is same, huh? If the airplane is at a height of 7.5 kilometer, what is the speed in meter per second? So as it has asked in meter per second, let me convert the kilometer into meter, 7500 meter. So I have time here I'll have to find the distance, this distance covered, then I can find out the speed, because that's what they have asked. So how do I do it? Again, the same method. You have the height here. So if you have the height, now in this triangle, this is the height, same height. Okay. This was 60 degrees. So this was 30 degree. This was 30 degree. So this part opposite to 30 degree, you will have 7500 divided by root 3. Yes or no? Right? Okay, 7500 divided by root 3. And this whole part would be how much? This is 30 degree, so this is 60 degree in a right angle triangle. So this part opposite to this part, whole part, would be 7500 into root 3. Right? Okay. So therefore, this part is the distance covered. This part is the distance covered. So that would be 7500 common root 3 minus 1 by root 3. Okay. So you can do this, directly from your memory also, because this would always come 2 by root 3. So if you have this 30 and 60 kind of stuff, you can multiply the height with 2 by root 3 and you will come with it. That's a shortcut. But a lot of times if you have to remember so many stuff, you might make mistake. Therefore, this is hardly 1 step, 2 step extra. You can do this way also. So your distance has come 7500 into 2 divided by root 3. Okay. And now this is in meter. And now you had also the time, that is 50 seconds. So multiply it by 50 seconds, you have your time. So this is gone, this is gone. 5 cancels 750, 150. So if you look at here, I am now getting 300 by root 3. But is 300 by root 3 in the option? No. Or there is no divided by option here. So what I'll do, what I'll do here is that I'll multiply by root 3, numerator, denominator, this would become 3, and here you'll have an extra 3. This would cancel 100 root 3. 100 root 3 is my answer, answer number B. You get your answer. So such easily you could have answered this question. So that was all. Thank you very much. Hope you liked the lecture and you understood the things that we discussed in here, and you would be taking home from here the concepts and your ability to master those concepts and applying those concepts to solving questions. Okay, right? So again, another time, happy Diwali to all of you. This time, let the real crackers be in the exam. Burst crackers in your exam. So all the best for your exam and have a blast this festive season. Double blast. Thank you very much.